Hello guys, let's find a general solution for this integral right here. X to the power n by x plus minus k whole to the power m dx, where n and m are positive integers, so positive integer powers, and k is a constant. Now, I'm going to give you guys a hint to kind of solve this on your own. So I'm going to give you the hint. Two terms stretch it out. So what does that mean? Well, we know two terms means binomial in mathematical terms, and stretch it out, stretching. When you stretch something, it expands. So expansion, in fact. So there we go. We have to use the binomial expansion from the binomial theorem. But if you directly try to do the binomial expansion here, you'll have a crazy denominator over here, but you can't really do the integral because you can really separate them, right? But what if the binomial expression was on the numerator, and when you do the binomial expansion, each of the terms you can just separate them out because they're just plus and minus, right? And then you can continue. So let's do that. So first, I'm going to substitute u as x plus minus k. Now, we need to find only for x on the numerator. So from here we get x equals to u. When k goes there, it becomes minus plus k. And dx is equals to, well, this is just du. So this integral becomes u minus plus k whole to the power n by u to the power m dx. And now you can expand the numerator using binomial theorem. So I'm going to do for a simple one over here, or over here, a plus b to the power n. So for the positive version, remind you here we have minus and plus, so minus plus, so we need to account for both cases. But however, I will just do the both cases in one expansion because you can in fact do that. Let me show you. C n comma 0 and a to the power n, b to the power 0, and also I'm going to write 1 to the power 0. This will be easier later on. So c n comma 1, a to the power n minus 1, b to the power 1, 1 to the power 1, plus you can see the pattern. And let's do for the general term. So let general term be r, such that we get a n minus, from here we can see it's r, and b to the power r, plus all the way to c n comma n, a to the power 0, because it will be n minus n, so that's 0, and b to the power n, 1 to the power 1, oh sorry, 1 to the power n, and I also forgot over here, 1 to the power n, plus blah blah blah. So that is for a plus b to the power n. Now, you'll see why I did the 1 to the power of these in just a few seconds. So, a minus b to the power n. So, this is when we have a minus in between. This is c n comma 0, a to the power n, b to the power 0. This part is exactly the same, except for this one, where instead we have minus 1 to the power 0. Because think of it like this. You're expanding a plus minus b to the power n. And minus b is just minus 1 into b. So whenever there is b to the power 0, there is also minus 1 to the power 0. And of course you can use the indices law, where if they have the same power, they too just multiply. So plus c n comma 1, e to the power n minus 1, b to the power 1, minus 1 to the power 1, plus blah blah blah, c n comma r, e to the power n minus r, b to the power r minus 1 to the power r. So this is for the general term, plus all the way to c n comma n, a to the power 0, b to the power n minus 1 to the power n. So we need to combine these two cases for this expansion over here. So we can see we have a minus and plus, and the only difference between these two expansions is that one is minus and the other is 1. So simply we can just write it as a case of minus 1 to the power 1 to whatever power, right? So let's just put it over here. So u minus plus k. So first we'll have c n comma 0, n is just the power, u to the power n k to the power 0 minus plus 1 to the power of 0 plus c n comma 1 u to the power n minus 1 k to the power 1 minus plus 1 to the power 1 plus all the way, or for the general term, c n comma r u n minus r k to the power r minus plus 1 to the power 1 to the power 1 to the power r blah 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 plus blah 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 plus c n comma n u to the power 0 k to the power n minus plus 1 to the power n whole by u to the power m, and of course you'll have a dx outside, so dx. Now the good thing about this is, even though it looks very crazy, here this c actually stands for combination, so where c n comma r is just n factorial by n minus r factorial by r factorial. As you can see, we know n and r because r is just a general term, so when we do it we'll just get numbers, so that means the combination part is a number. But here we know k is a constant, and since k to the power n power is constant, they're all constants, remaining just u to the power something, right? U to the power whatever divided by u to the power m. Now we can separate these integrals due to this plus over here, and of course you'll get minus when you multiply this. So you'll just get u to the power whatever by u to the power m. So let's take for the general case u to the power r by u to the power m. Here you'll simply get u to the power r minus m to some constant, let's say a1, or let's just say some other constant. So let's account for those constants, right? So let's say these constants multiply out in every term, and I'm going to represent them as a naught, right? A naught u to the power n plus a1 u to the power n minus 1 plus blah 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 ar u to the power n minus r plus all the way to an u to the power n minus n, which is just, we can write that 0. Now we can expand this. So this is just a naught integral of u to the power n minus m dx plus a1 integral of u to the power n minus 1 minus m dx plus blah 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 e to the power r e to the power n minus o integral of u to the power n minus r minus m dx plus a n integral of u to the power 0 minus m dx. So obviously here you can simply use the power rule. So this is a naught u to the power n minus m plus 1, and then you have to divide by the new power, which is n minus m plus 1, but we can directly substitute in u as that, so you get x plus minus k to the power n minus m plus 1 by n minus m plus 1 plus a1 x plus minus k n minus m minus 1 plus 1, which is just n minus m by n minus m plus go on forever, or not forever, to the general term x plus minus k to the power n minus r minus m plus 1 by n minus r minus m plus 1 plus e to the power n x plus minus k u to the power just simply minus m plus 1 by minus m plus 1, but don't forget the most important part, plus c, and there we go.